Welcome all of you dear students. This is the simplest and easiest way of teaching learning process in our most popular YouTube channel. Physics Make It Simple by Dr.Rajendra now serving as a principal in Lokanete, Dr. Balasaheb Vikhe Patil, Padma Bhushan awardee, Pravara Rural Education Societies, Mahatma Phule Vidyalaya and Junior College, Dad Budruk Taluka Rahata District, Ahmednagar. Time is exactly approaching now Saturday night 11:45 pm. As long as wave optics of 12 science is concerned, dear students, I have already uploaded 5 lectures, and in that 5 lectures we have learned introduction of wave optics, wave nature of light, corpuscular nature of light, dual nature of light. What is the concept of wavefront? What is Hygiene's principle? How the construction of spherical wavefront is to be done? Construction of plane wavefront. Reflection of light at a plane surface. That all things we have already learned in 5 lectures, dear students. So, at first listen that 5 lectures one by one, gradually, very carefully, and then we are going to approach now after a long interval of time, because we have completed oscillation at first, and then in this lecture, as long as wave optics is concerned, we are going to discuss very interesting article, refraction of light at a plane boundary between two media, and this is a lecture number 6. So observe the diagram carefully at first. While drawing the diagram of refraction, most important point, dear students, is for the refraction phenomenon we require two media. Velocity of light in rarer medium is denoted by C1, while velocity of light in denser medium is denoted by C2. This is the first thing that you keep in mind. Okay, this XY is a plane boundary between two media. Okay, while drawing the ray diagram, be careful that incident ray should be more inclined. Draw the incident ray having more inclination so as to easily draw refracted ray. This is the another clue while drawing the ray diagram. Observe the diagram carefully. It is a very simple ray diagram, and I have written a very simple note to you for your writing purpose as long as any type of examination is concerned. Okay, see here. I have written here source is at infinity. Why have I written source is at infinity? We know to get a plane wavefront, source should be at infinity. And here is a plane wavefront AB which is produced from the infinite source. So in the diagram itself, I have written a sentence, source is at infinity, so as to get plane wavefront AB. This is the first point. Now, this AB is a plane wavefront. A reaches to C, B reaches to D, so CD is also a incident plane wavefront. EF is a refracted plane wavefront. This is an incident angle, this is a refracted angle. P and Q are the incident rays. Ray R and ray S are called as refracted rays. These are the two normal lines. We will denote it by M and N. I will denote it. This is M is a first normal. This N is a second normal. Okay. Then the description given in the book is somewhat essay type, not necessary to write all the descriptive part as long as the examination point of view, because we will have to write, as long as the examination is concerned, very systematically in a proper manner. That I have tried here. See here, the first sentence I have written source is at infinity. Then AB is a plane wavefront. This AB is a plane wavefront bounded by two rays, bounded by two incident rays P and Q. This is the second sentence. The first sentence is source is at infinity. Listen carefully. Very simple. Very simple. Listen carefully. Source is at infinity. AB is a plane wavefront bounded by which rays? Bounded by two incident rays P and Q. This is the second sentence. The third sentence is when A reaches to C, at the same time B reaches to D. This is the third sentence. The fourth sentence, as soon as the C touch the XY plane, this C acts as a secondary source. Hygiene's principle start. This C acts as a secondary source, starting emitting secondary waves in all possible directions to form a spherical wavefront in denser medium. This is a denser medium. This is a rarer medium. This is a denser medium. I will repeat again. C acts as a secondary source, sending out secondary waves in all possible directions in the denser medium to form a spherical wavefront as shown in the figure. Okay. Next sentence. When C reaches to E, at that time D reaches to F. That this D covers longer distance up to F. This is a longer distance. At the same time C reaches up to E. This is a smaller distance. Why this happened, dear students? The time is same. Simultaneously, when C reaches to E, at that time D reaches to F. This is a longer displacement. This is a smaller displacement. Why this happen? The answer is, this is a rarer medium and this is a denser medium. And we know velocity of light in a rarer medium is larger and velocity of light in denser medium is smaller. So here light travel faster, and so that it covers larger distance, and so that I have written here length of df is equal to c1t, where c1 is the velocity of light in a rarer medium and c1t is a distance covered during the time t. When d reaches to f, at the same time c reaches to e, so length of ce is equal to c2t. So, and draw tangent to the spherical wavefront EF, we get two triangles CEF, another triangle is CDF. This is an incident angle, this is a refracted angle. This is incident angle, this is refracted angle. The most important concentration is now, dear students, how this is incident angle and how this is refracted angle. Very important. So consider the triangle CDF. We know sum of all angle is 90 degree. So sum of all angles is 180 degree. So angle D is 90 degree. I will write here. Angle D is 90 degree. Suppose we don't know this angle. We don't know this angle. I will write this is X plus. What is this angle? If this angle is I and this angle is 90 degree, then this angle should be 90 minus I. 90 minus I. This is 90. We don't know this. I will keep it as a X plus this angle is 90 minus I, which is equal to 180. This 90 plus 90 we get 180. 180 and 180 get cancelled, and you will get x is equal to I. So I have written I here. How this I comes? Not necessary to write as long as the examination point of view, but we should know how this I comes. Okay, then I will remove this. I will remove this. This is only for your understanding purpose. Then how this R comes? This angle is 90 degree. This angle is, this R, this angle is 90. See here, see here, see here. This angle is 90 degree like this. Out of that, this angle is R. What is this angle? This angle is 90 minus R. 90 minus R. This angle is 90 degree plus this angle is suppose Y, which is equal to 180 degree. This 190 plus 90, we get 180. 180 and this 180 get cancelled, and you will get Y is equal to this minus R on the next side. Y is equal to R. In this way this R comes. So blindly we can write I here and R here as long as the ray diagram is concerned. But how that come, that I have already explained, not necessary to write in your note. Okay, I will rub out it. So have you understood how this I and R comes? Have you understood how this I and R comes? If you haven't understood, then pause the video and again repeat my lesson so as to understand how that I and R comes. Okay. In short, I will repeat again. Source is at infinity. This is first sentence. P and Q are the incident rays. Second sentence. This AB is a plane wavefront bounded by these two incident rays. Third sentence. When A reaches to C, at that time B reaches to D. When A reaches to C, at the same time B reaches to D. This is the fifth sentence. As soon as C touches the plane boundary, this C acts as a secondary source, sending out secondary waves in denser medium to form a spherical wavefront as shown in the figure. When C reaches to E, at the same time D reaches to F. D covers longer distance because velocity of light in rarer medium is larger. That I have explained. And so that dF is equal to C1t and CE is equal to C2t. Then draw tangent EF. This tangent EF is nothing but a refracted plane wavefront. This CD is nothing but the incident plane wavefront. I will repeat again. CD is nothing but the incident plane wavefront. EF is nothing but the refracted plane wavefront. How this incident angle I and R comes, that I have already told you that. So this is all about explanation. Then the next point is to prove laws of refraction. So for that purpose, consider two triangles CDF and second triangle CEF. These both the triangles are rectangular triangles. So from CDF, sin I is equal to front side length of DF upon diagonal, that is CF. See here, length of DF upon CF. What is sin R? Sin R is equal to front side length of CE upon CF. See here, length of CE upon CF. Then I have taken ratio. Sin I upon sin R is equal to length of DF upon length of CF. This formula multiplied by this denominator goes up and numerator goes down. We get what? Length of CF upon length of CE. Then sin I upon sin R is equal to what we get? The C upon CF get cancelled and you will get what? Length of DF upon length of CE. But we know, dear students, what is length of df. See here, length of df is equal to c1t. What is length of ce? Length of ce is equal to c2t. What is c1? Velocity of light in rarer medium. And what is c2? Velocity of light in denser medium. Then tt get cancelled and you will get what? Sin I upon sin r is equal to c1 upon c2. This is equation number 3. I have taken this equation 1, this is 2 and this is 3. But we know mu1 2 is equal to sin I upon sin r. This general formula we know. What is mu1 2? This is refractive index of second medium with respect to first medium. But first medium is rarer medium and second medium is denser medium. So we can write like this: mu1 2 is equal to Ri of denser medium with respect to Ri of denser medium with respect to what? I have done mistake here. Ri of denser medium with respect to what? With respect to rarer medium. Okay, this is correct now. mu1 2 or mu2 1 is Ri of denser medium with respect to rarer medium. And so that combining equation 3 and 4, sin I upon sin r is equal to c1 upon c2. But we know mu2 1 or mu1 2 is equal to sin I upon sin r, equation number 4. Combining and comparing these two equations will get what? Mu2 1 is equal to c1 upon c2. And this is called as Snail's law, dear students. This is Snail's law. And in the next section, we have to prove that C1 is greater than C2. The answer is very simple. The LHS is nothing but the refractive index of denser medium with respect to rarer medium. This refractive index of denser medium with respect to rarer medium is always greater than 1. Remember well, dear students. mu1 is always greater than 1. And to get this LHS always greater than 1, 1.2, 1.3 like this, 1.4, 1.5 like this. So numerator value should be greater than denominator value. If this is greater than 1, then numerator must be greater than C2. Numerator must be greater than denominator. And so that I have written here, Ri of denser medium with respect to rarer medium is always greater than 1, implies that from equation 5, velocity of light in rarer medium, that is C1, is always greater than velocity of light in denser medium, that is C2. And this is a proof of Snail's law. And from this, we have to write now laws of refraction. So, for writing the laws of refraction, take a screenshot at first, read it carefully, listen this video again and again, and the last one point is remaining that I will write on the board and explain to you, that is laws of refraction, and that is a section number 6. This is a section number 5. Take a screenshot. I will wait for some time and take a screenshot. Okay. Then what is laws of refraction? I will write that laws of refraction here. I will write laws of refraction here. See here. Laws of refraction. Okay. Let me clean the board at first. Okay, here we'll write laws of refraction. This is section number 6. This is section number 5. I will write here laws of refraction. Number A. The first law is what? The ratio of velocity of light in rarer medium to the velocity of light in denser medium is equal to refractive index of medium, which is constant. Which is constant. I will write ratio of velocity of light in rarer medium C1 to the velocity of light in denser medium C2 is some constant known as Ri of denser medium with respect to rarer medium. This is the first law. The second law, dear student, is incident rays, refracted rays, normals. These are the incident rays. See here, incident rays, these are the refracted rays, these are the normals, lie in the same plane. Simpler. Okay, I will write here incident rays, refracted rays and normals lie in the same plane. This is the second law. Third law, incident rays and refracted rays are on opposite side of the normal. Okay, incident ray is on LHS side, refracted ray is on RHS side. Incident rays and refracted rays are on the opposite sides of the normal. A, B, C, D. What conclusion we got here? Velocity of light in rarer medium is always greater than that of velocity of light in denser medium. This conclusion also we can write here. Velocity of light in rarer medium. Velocity of light in rarer medium, that is C1, is always greater than that of denser medium, that is C2. So these are the 4 remarks. We denote it as a laws of refraction. The question asked in this article is like this. Number 1, draw a neat labeled ray diagram of refraction of light at a plane boundary between two media, for 2 marks. Second question, explain refraction of light at a plane boundary between two media. Title question. The third question for 3 marks. The third question is that prove laws of refraction of light at a plane boundary between two media. In this way, or sometimes only for the 2 marks, the question may ask state only laws of refraction. So we can state only that laws. So this is all about refraction of light. Many interesting and funny articles as long as wave optics is remaining, dear students. So subscribe my channel, listen my channel again and again, see my videos for your good study, for best study, to get a good number of marks as long as examination point of view. So be alert, remain alert to see my channel Physics Make It Simple. We will again meet by taking a next interesting article in a next video. Till goodbye.